Long time no tune stream. Whoops, it's over. Whoop, whoop, whoop. Long time no tune stream. It's been a while. I've been tuning, not much, a few things here and there, but I had some stuff going on that I had to take care of. Forgot to punch some Dyno's data in here. Let me get that real quick. Hey. That motherfucker is welcome. Come on over. Let's get this done. I got no fucking time for that. I'm not gonna go hunt him down. Although I kind of want it.
No, I don't even think you'd make it. Tanner would see out there on camera. Go out and get the person in.
I don't like fighting because I feel like I'm so angry inside. I don't know if I'd stop when I should stop. But maybe not. Maybe I'm like super mellow and shit. But things have changed as I've gotten older, so my regard for human life has definitely gone down.
See, that's the opposite for me. For me, fighting is more like relaxing than it is anything. And I think it's relaxing for me because like I can express my anger and I don't even feel my anger. Like when I argue.
I'm laughing that you said express my anger. I mean, a lot of people express their anger in fighting.
When you yell at them, like if you yell at somebody, you don't know if they fully understand. But when I punch you in the face,
you understand?
You understand.
Yeah, my big fear is that everyone's fucking packing these days. And
Yeah.
you just never know which guy is such a fucking pussy to get his shit kicked in and he's like, hey, I feared for my life because he had a big bad fist.
Right.
Where the fuck did my kid go?
Every time I jab you, I can physically see what I want you to feel.
Right. Yeah. So, hello. I had a guy, a friend of the customer whose car I'm actually about to tune, who emailed us and threatened me.
Oh, you're on YouTube.
I am now, yeah. Threatened me that this car wasn't fucking perfect. He was gonna come kick our asses. And I was like, why wait? Come on down now. He never did. That was like a year ago or something, or 6 months ago or whatever. I don't fucking know anymore. So we were just joking around about that. About what a fucking clown that guy is. If my friend's car is not perfect, I'm gonna kick your ass. Okay, buddy. Okay. Anger problem much? So this car is a 2006 STI with a built motor, ported heads, aftermarket cams. I think cams. Let me check. I thought it was cams. It's the wrong map. Get the right map. It's got some FP thing, I think a green or something. I'm not a FP green nut swinger by any stretch, or FP turbo by that matter. I'm not a big fan of their turbos. But this is one of those cases where the guy brought a bunch of his own shit, and also one of those reasons why we send those people away now. If they show up with a bunch of their own shit, we're just like, no thank you, go find another shop that'll do that for you. I'm not going to install the crap that you bring to me. Just not. Can't provide you any warranty service on it when it fails because you bought it, not us. I can't support you in the product. So like, if I'm not going to support the product, then why would I sell it or install it, or in this case even tune it? I want my customers to have good stuff on their cars. I want their cars to last, but I also want the way their cars operate to reflect on my abilities and my decision making. I don't want someone's car to run like shit because it has shit fucking parts on it, and then have people think that the reason it runs bad is because of my tune, right? And so I just don't do it. Like, no thanks. I want the car to run really well. And I want you to be. I had another customer who was clearing his check engine light. Every time he overboosted, the line popped off the nipple on the turbo, or maybe it was the solenoid. One of them was the feed line. And he was hitting like 38 pounds of boost in his STI, and he just would reset the check engine light and go hammer it again, and then reset again, and go hammer it again. And I'm like, what are you doing that for? You know, he's like, oh, I thought I was at the end of the tune. I don't know what end of the tune means, but he thought he was at the end of the tune, and that's why he kept getting the check engine light. Still trying to understand what the fuck that means, but that was like fucking 8-10 years ago. It was a while ago now. And yeah, it blew up, of course. It fractured the shit out of cylinder 4 piston, just shattered it practically. The guy tried to take us to court over it, said it was our fault. It was our fault that he ignored the car saying, holy shit, the boost is too high! And then it was our fault, so he didn't win. He didn't win, which is good because he didn't deserve it. Like, he fucked it up. The car literally said, ouch! Boost is fucking too high, stop doing that. And so that was easy to. Oh, FP red. Yeah, that was a green. It's a red. So it's a red 13 hundos. Cobb 4-bar map sensor. I thought it had IAT relocate. Turns out it doesn't. So that's irritating. But we're gonna be operating it MAF based anyways with a Cobb SF, and not speed density, although right now it's set for hybrid speed density, but once I learned that there was no intake air temp sensor in here, hybrid speed density is not the right thing to do, so that's not happening. Pump. I think, yeah, there we go. Alright, so the car's got some misfiring going on. Idle. It's not common on 13s for it to misfire at idle, but it can. They can do that. And I'm not liking it. I wish it would stop doing that. Bad car. Stop it. It's got a lag gas FP red on it, so that makes that boost curve really cool. I get to make it look like an exponential curve or a bicycle ramp or something really fun. You know, and they hit hard when they show up. It's like if Mike Tyson was late for every fight that he went to. You know, and when he finally got there, motherfucker hit hard. But that's one of the things with journal bearing turbos, right? Journal bearing turbos they don't come in as smoothly on the bottom end, and then when they do come in, they tend to be pretty dramatic, you know. And this one is going to be pretty dramatic. It's a red. That's what they do. But boy, when they come in, our highest power record on this dyno for a long time was actually on a red. But that was only the first year of owning the dyno, right? But still, in that first year, the FE Red held the record. It was, I think it was meth injected or something like that, and it made like 500 and something wheel. It used to be written on the glass, but we've blown through that now, so that's not on the glass anymore. So right now, I'm just building a boost map, setting the boost limits, boost target. I'll set all that stuff up, get rid of the rev limiter because it's a brand new motor on a break-in rev limit. Get rid of all that, and then flash this map as like a base, and then start to troubleshoot the misfiring. If it's just a slight imbalance in injectors or what, maybe grounds, maybe very much stuff. What was something like that? Legacy will get swapped at Tier 1 soon. Oh, I don't know about that. I don't know what you mean by swapped. And you got the word legacy in there, so I can't promise that. Depends on what you're doing. What are you doing? Let me know. Legacy ECUs fucking suck, Travis. I hate dealing with legacy ECU. They often develop these weird knock things where, like, where the ECU just starts pulling much timing at random. Version 8 in a legacy. So you got 20 grand that you're ready to blow. Version 8 207 swap in a legacy. That's a complete wiring merge. That's cross member, the whole engine. That's 30 hours of labor. That's like, if you keep your factory transmission, that's like 12 grand. And if you go with a 6-speed, you're looking at almost freaking, almost 20 after all that shit's, you know, done. I don't know a legacy that's worth dropping 20 grand into for a swap. You gotta really like the chassis for that. I love 207s, but it's just not something that's very economical. And then in the end, what do you get? You get a 360 horsepower car. Like, fuck, I could spend 7 grand and get a all-wheel drive BMW 335i that's got creature comforts and has, you know, 300 horsepower, and they do a flash and it's got 400 horsepower, which is the flash and no mods. 05 to 09 GT are a good looking car inside and out. That's an opinion. That's an opinion. Yeah. Good for you and your opinion. I think the 05 and 06 are actually quite ugly on the outside. The jack-o'-lantern taillights are fucking ridiculous. And yeah, the soft front bumper that kind of comes down to something weird. I don't like it at all. The 05. When it first came out, I was in love with it, but then I started noticing how it's like a hot chick with like a really, really weak chin. It's like tucked in her hair, right? Like she's so hot, but then her chin like lower lip to like, you know, throat kind of thing going on. It's like a straight line, and you're like, God, it's so close. Like it was fucking right there. Yeah, that's what the 0506 looks like. But the 07's gonna change, right? 7, 8, and 9 are different. Look at that. Text from the wife, and the phone jumps off the fucking dash. Better check that shit. It's your wife. Is it 08? Okay. I think the 08 is better looking by far. They shrunk the tail lights up. They had the little sub ones in the bumper. Front bumper is even a little, you know, flatter and square and well, straighter, I guess. I don't know if I say squarer, but it's got more substance to it. It doesn't look all, you know. I definitely like the 08 better than the other ones, for sure. Teresa had a white one. It was really good. I had an 06, and it was all right. And then the fender's a nice edge to the headlight. Yeah, that looks really cool. The headlights are a little bigger. They have a little more at the end, and that ridge that follows the headlights really nice. 98 GT. Yeah, that sounds like what we did with Garris. Garris had 98 GT. I think it's 98 as well. It's got a built 2.5 and 2.3. It's got a 2.3. That's right. It's got a built 2. It looks like my car, but better wheels. Stock wheels. What if he wants to trade? Oh, this is that kid. I still should trade him wheels. I got those white fucking gram lights on that red STI that I bought that I can't stand. I don't like the red or the white gram lights. He's gonna fucking hit this car. This is the poor guy that could not figure out how to get a map that I emailed him onto his access port. It's been a thing for like 3 weeks now, and he has not figured it out. I finally stopped answering emails. There's only so much I can handle. I am only one man. Alright, so I'm going to turn the camera in just a second. I just want to finish up this stuff. Holding the camera and doing tuning is not conducive to good results for the stream or the tune. So I just want to finish up these base parameters. And then I'm going to start doing some stuff. This car should make some jam, really. I mean, it's got cams, it's got porting, it's got a big turbo, it's got big injectors, it's got a front mount. Like, it should make some good power. So that'll be fun. It'll probably sound really good too. I think. I haven't really listened to it much. Alright, so before I flash this, I want to look at my learn trims that are on the map already and see how close I am. Just to make sure. I've been driving around for 2 weeks now on the break-in tune. Granted, like I said, I thought, hey dude, I thought the break-in tune, James, is that what that was? The break-in tune had the intake air temp sensor, so I'm not sure how much it has changed or how far off it was. So I got -1% at idle, 1.7, so that's really close. But then I got -15% at 5.610, so that's high idle, and then +1% from 1 to 40 and 0 over that. So there's just that one zone from caught my stream fail. Yeah, the camera wouldn't rotate. I always start it, turn it, and then it says, do you want to do it in landscape? Yes. Okay, good. Click this button and continue. And then I rotated it, and it just said, hey, go back the other way. It never asked me to do it. And I even took the fucking, the thumbnail for the video in landscape too. So, like, clearly that's what I want. No, fuck me, right? So anyways, yeah, I got this one spot. It's a total of 4.4 grams of air range. That's, for some reason, is -15. So that's weird. But fixing all that, hopefully, and we'll figure out why this thing is misfiring so much on cylinder 3. It misfires on all of them a little bit, which is very much going to most likely be the injectors. Where's this guy at? Right there. So here's something a lot of people don't know. Yeah, I gotta hope not. It's a fucking brand new motor. You know, ID injectors, they provide you plug-and-play data. And all the plug-and-play data is exactly the same for all the injectors. But you know what's not exactly the same? All the injectors. Now, the ones that you buy are all the same. And so they all have the same characteristics in low pulse width regions and everything else. And they're like the only manufacturer to do that to such fucking precise amount, like to such precision. That's very awesome that they do that. But the data still varies from the injector set you get. So it may not be, oh, that's not right. It may not be totally accurate for the injectors you get. Not a lot of people know that. They're not technically very far off, but they can be off a little bit. And that is something that your tuner needs to be aware of and be ready. Sorry, something distracted me. Anyways, needs to be aware of and be ready to adjust. And usually it's just small changes in the low pulse width region. As you get into that lower end of it, each injector set is going to have a bigger difference from that baseline data than what you get. Typically it's really close around the 2 point whatever and 1 point whatever to 3.0 milliseconds, but down in the lower regions of it, you could have an injector set that's flowing like 5 to 10% more or less than the data they give you. And so you need to know that when you put the data in there, it's not always going to be exactly as they put. The latency is almost always exactly the same. That's so much of that is a construction thing with the injector that that it's almost always the same. Really, really close. I've had a couple. I've had to tweak it like just a teeny weensy bit, but the latency is almost always right in there. The scaling is always really, really close in there as well, because that scaling is really the top end flow, the low end flow, and top end wise, they all flow really freaking close. It's only that very, very lowest low pulse with that any injector, but the ID injector specifically in this conversation, start to deviate from the data that they provide you. And that is totally okay, right? Because you're already so much closer than any other injector on the market. But you just gotta understand when you go to tune them that you may have to tweak that very bottom end of the low pulse region. If you look at the injector deviation that they posted a long time ago, they showed that the same injector provided from Bosch, I think it was ID 1000s at the time or something along those lines, they were getting from Bosch, they were getting like plus or minus 6 or something % down at the lowest regions. And so if you just bought, you know, whoever's, you know, Bosch 1000cc ID style injector off of eBay, then what you could have is one injector that has 6 above the median and another that has 6 below the median for a net delta of 12% off in the low pulse region, and you have injectors that run like shit. And what ID does is they take all the injectors and they flow test them all, and they get all this +6s and put them together, and go the -6s and put them together, and get, you know, all the zeros, put them in, and they get them all like in there. And I know they have a range where that falls outside of their acceptable data limits, and I don't know what it is. Those 6s might technically be out. They might only, you know, allow ones that come in to be, you know, within the 3%. I'm sure it's more than 3%, but a long time ago, I purchased some out-of-spec injectors where they get them as matched as they can, but they don't fall in line with their plug-and-play data as well as they want it to, and they're called out-of-specs. And so then you gotta like put their base data in there and then fuck with it a lot to get them to work. And so at the time, I did buy some off-spec injectors for my Corvette. They're not installed. I actually ended up buying different injectors for the Corvette anyways, but that's where they start off. That's what I bought initially. And I will probably still use them at some point. I just haven't yet. So, anyways, enough of that shit. So, -15, okay. Now, it had some weird math on it that I've never seen, some balloon math on it. So, the math scale that I put on it was pretty much a guess, really. So, I'm not too upset with the that one spot that was 15%. Okay, that was really weird. Oh, okay, got it. So yeah, so I wasn't very upset with that one area. So now what I did is I loaded just the real time from that map that I adjusted. So the rev limit's up, the boost is different, and a few of the things are different, but not some of the hard stuff that I flashed. Hold on a second. What's up, bud?
Your boy Daniel's here.
Yeah?
Yeah.
Did they figure it out?
It just showed up.
Oh, I saw him pull in. It took like 15 minutes from the park.
Yeah, it was a miserable conversation, and I was just asking what he was doing here.
He's got to get his shit fixed, huh? I mean, Chase should help him.
What?
Chase should help him.
Yeah, he's got it.
Okay. Alright, so now we're going to look at the log again. And now I'm at -15 learning at idle. That's interesting. I put a new mass airflow sensor on it just now in a Cobb SF, so it's going to be more off from where the tune was originally. But I still wanted to see like where it was and how far off it was. Oh, but my math cal didn't transfer over. So let's fix that. That's why there's a -15 in there. I must have goofed something up, didn't realize it. Or I had a glitch. Glitches do exist, let me tell you. Hey, look at that. Fucking correction learning. Fucking straighten stuff right out. Alright, so here we go. La 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 la. So that learning there was -15 just a couple seconds ago. And since the tune's so fresh, I should say there was less runtime on the car, then it very quickly fixed the learning in that region now. Now, actually what could have happened, I didn't check, is that it's possible that the new math scale pushed me into a lower region of learning as well. So that's very possible. And maybe the next session is still 15. But when I change the scale, let's bring it up some, see what we got. Yeah, that must be what it is. I don't see mass airflow on my dog. I failed. Perfect. I hear noise like it's got bad coil packs or bad grounds or something. Like it doesn't feel clean. Like I'm listening to the engine, it doesn't feel clean or sound clean. Now, ignition timing has a strong impact on the engine not feeling clean. But you look here, I got 36.5 in this no loaded region here, which is a lot of timing. In some cases though, depending on what chamber's in it and what compression ratio is, it might want 45 degrees. And you can do that and put it to 45 and then hear the engine change tone and the engine's like, like I'm happy. Actually this is, so that's what's in there now. That's stock. You can see I got like negative 13 degrees from the stock tune right here in this region. But if you look up here, you'll see that my load's a lot higher because I had to expand the load out. So where the load difference is smaller, like half, still 11 or 12 degrees. Now why is that? Well, the factory tunes are fucking aggressive when it comes to ignition advance. If you want to keep cylinder 4 intact, you got to bring that shit down. But 2, because I extended the range on here, and because the engine is slightly higher compression than the stock, and because some of that timing is located in the dynamic advance map where it's not in the factory tune, then that's why you see these big differences here. But right now we're down here. We're not looking at it or like that. Obviously, to do that, we got to unload the comparison and then hit T for trace. And you see we're right there. Now, let's add timing to this and see if the engine sounds any different. We're gonna go 50 degrees right here. It did sound different. And it sounds smoother. That's very interesting. I don't know if you guys can hear that or not. Timing went to 49 after that. I'm gonna do it again. I'm gonna go down. So let's do this. Right down to 35. You hear that? Hear how the engine is rougher in that range? So that's a function of a lot of things. Let's go 55. Look at that. Think how much more torque is generated at the same throttle input with that much timing. That's interesting, right? I mean, it was already at 36, and I put it at 55, and it smoothened out and made way more torque. RPMs actually jumped. Now, let's think about that for a second. Like, hold on a second. I have less timing on the top end. Wow, I got my nails. Less time on the top end by a lot. But I'm gonna have more time on the bottom end by a lot. Seems weird, right? Well, if you consider the modifications of the engine and what's done to it, then what you have is some things that will give you that type of trend. It's got bigger cams in it. So if I have bigger cams in it, I have more overlap. With more overlap comes more retained exhaust gas. With more retained exhaust gas comes a slower burn. When you have a slower burn, you need more timing. So in the low end, all of a sudden, the fact that I had more timing to make the car run smooth makes sense. If I have more exhaust gas and a slower burn, I need more timing. Well, at 3,600 RPM, the AVCS in that range was like, I don't know, what was it? Let's go back up to it again. What did I have it at? 20, 15? 15 right there, 12. Right around 12. Now, if I add even more timing, or advance to that, cam advance, I would need to have even more ignition timing because I would, again, retain more exhaust gas. Oh, wait, but maybe I wouldn't. And why wouldn't I? Well, when the exhaust cam closes earlier, you have higher compression. You trap more of the air in the cylinder and compress it. So now I have more stuff in the cylinder versus less stuff in the cylinder, so I might not need more ignition advance. But as for where it was right now, it was clear the engine wanted more. It was very clear that it wanted a lot more timing than it was getting. So what we're going to do is we're going to advance the cams a little bit in that region. And here's the map it's in right now. Like I said, it's got aftermarket cams. It's got a lot of 20s in there, right? That's where I'm starting off. I'm starting off in this area, but right here is where we're revving it between these two areas. So I'm going to take this whole zone again, and I'm just going to make it all 25 because I want to see how it behaves in that region as I rev it up again. So I'm going to do it again. All right, now I felt the vibration when that happened. Right as the cam started to advance, I felt the vibration in the engine. Yeah, you feel it pretty firm in the pedal. And then it goes away as I get about 2,400. But when I pass through that 2,000 region, as that cam is advancing, there's a pretty wicked vibration and I'm not monitoring misfires, but I would bet those are all misfires. If they're the cam touching the piston, or the valve touching the piston, oops. Just kidding. That would be a lot more just a vibration. So we're going to 20. Still a perceivable vibration right there at 2,000 mark. So I'm going to come back down again to 15. Let's see how that vibration is. Okay, it's much softer. Like I can almost feel it right as it starts to advance. Right there, I feel a little bit. So at these low RPMs, when you would hope that the increased compression provides you more engine torque and smooth it out, the increase in overlap was actually overwhelming that benefit, with the negative being I'm pumping a bunch of exhaust gas in there, and now it misfires. So we're going to 10 again. Actually going to lower than before. Alright, so let's go back to my timing. I forget what that at. Is it still at 50? Yeah, timing's still at 55. I'm actually going to make this cell also at 55. So this whole area here is 55, which is a lot of fucking timing, right? But if it's a slow burn, you just might need it. So we're going to hit this again. Yeah, right there, it just doesn't like that much advance right there. Okay, with the extra advance, I'm going to drop the timing a few degrees and see if the vibration goes away. I've been assuming that it's from overlap, but I didn't verify it was from ignition advance. Let's do it again. Okay, that felt all right. Let's go back to that advance again. Let's do that one more time. Do this whole cell back to 25 and feel it. No, vibration's back. So with reduced timing and the increased reduced ignition timing and increased cam timing, that vibration is still there. So it tells me that the cam timing is the dominant factor, and that I don't want the extra cam timing, that the engine doesn't want that cam timing. Now up here, it's going to want that fine, right? And why is that difference there? Well, that's nice of him.
Yeah.
Hey, Justin, I got your message. Hey, man, there's no hard feelings towards you at all, just so you know that, all right, bud? None at all. I don't know what that dude's trip was. It went on for like 2 days, the dude sending me messages and threats and stuff, so. But no hard feelings towards you at all. I honestly just think it's a funny story. So, you're good, man. You're good, we're good. No sweat. I appreciate the message, though. What was I saying? Okay, anyway, so now up here, the more advanced is definitely going to be more advantageous for us. The reason it was bad down here is because we were still in a lot of manifold vacuum. And when both valves are open and overlap, manifold vacuum is really high, and you suck that exhaust gas into the intake manifold, right? So you retain a lot that way. It sucks it right in. Now, up in this region, though, this is where we're going to be at atmospheric pressure or even boost. And in that situation, you're not going to retain any extra exhaust gas with the overlap, because the intake manifold and the exhaust pressure are going to be really close to each other, and so you're not going to pollute the intake with a bunch of exhaust. So up here in this region, I can go 25, 30, sorry, excuse me, and my lunch wanted to say something. 25, 30 degrees in this region, and I'll probably gain a lot of compression and a lot of torque in that region. Depending on the size of the cam, though, 20 may be all we want. So, but down here with the high manifold vacuum, the advance was not good. It was sucking in a lot of exhaust gas in there. In fact, I'm just gonna run 0. I'm gonna run 0 for the sake of this discussion. I'm gonna feel. Obviously, you guys can't feel it. I don't feel any vibration actually through that region with 0. Let's see if I do it again. A little slow. Oh, a tiny bit. I hear a little bloop, bloop, bloop out the exhaust. A few pops. Now that's the pops that I was talking about earlier that I was afraid might be something with like a ground or a weak coil pack or something. Now, if it's a weak coil pack, we'll definitely know when we get to add power. If it's just noise from grounds and that kind of stuff, we're not going to know right away, unless we start replacing shit and throwing parts out or whatever. But overall, we might want to work on the grounding and see if it's any better. But I'm going to keep on with the tune and see if it causes any problems as we start approaching these regions. If it does, then obviously I can't ignore them and I gotta get it done. But I only have so many slots on my schedule to do tuning and that kind of thing. So, yeah. All right. So let's go again. So there's a little bit of a burble there. I'm gonna go back to the timing again because I still have that set at 45. Let's go back up to 55 where it seemed to be happier. And then we'll hit that region again with 0 cam advance. There was a little bit of vibration right here at that one, so that might be too much too soon. I'm just gonna take some of it out and let it come in at 2400. Still there. So I go up and down with timing. I go up and down with the intake cams. I'm still getting a little burble in that area. Now, what I say earlier, it could be the injectors, right? It could absolutely be the injectors. This region is in high vacuum, low airflow. Like the pulse width is going to be really, really small, and we're asking these injectors to feed an engine. Let's see. Do I have the pulse width on here? I don't. Okay. And the car still feels good on a rev, right? The car still feels great on a rev. But let's go and add a pulse width on here just real quick. No latency. All right. Now let's do it with both, so we can see how much of it is. How much of it is the fuel being requested, and how much of it is just compensating for battery voltage, right? That's the difference here. This is provided that my latency is correct, right? Provided I put it correctly in the map. This value is how much the injector is actually open. This is how long I'm asking it to be open, how long of a signal I'm giving it. But since it takes time to open, this is how long it's actually open, right? And that's important to know the difference between the two of them. And so this here, technically, is my requested fuel mass. I'm gonna let you think about that for a second. This is my requested fuel mass. Okay, and as you can see, my requested fuel mass dips down into the, or well, that number does not mean the fuel mass. The number is me asking the engine to provide that a fuel mass. So I would take this times the injector flow rate and figure out what mass I was giving it. Okay, so you see now that at idle, the engine requires exactly, Travis, exactly what I was just about to say, is that it takes more fuel at idle than it takes when the engine is up at those RPMs. And so sometimes an injector might do just fine at idle. The pulse width is just long enough that the low pulse characteristics are linear enough and the injectors are balanced enough that it's actually okay. But then when we get up into this high vacuum region and the injectors start to give us an even shorter pulse, then things can change, right? It can run. In the case of the Link ECU in my RS, when I hit that region, it throws me a warning and says minimum pulse width or minimum calculated fuel mass limit hit, or what the fuck, it's something along those lines. Basically, it's telling me that I don't, no problem, but here in this region, the pulse width gets so short that my minimum pulse width is being hit. That my calculation says I need to fire the injector for less time than the injector is rated to fire. And I also have 13s on my car, just like this one here. So that's something to keep in mind. So if you start getting these things here, but how often are you gonna hit this spot? How often are you gonna be high vacuum, no load, this RPM? You're not gonna get it very often, right? It's not gonna happen a whole lot. So it isn't a huge concern, but it is a data point for the tuning process, so I can get an idea of how the cars behave, whether you know, things. It's really amazing what the engine tells you when it's in high vacuum sometimes. High vacuum is a high vacuum is hard to attain, is basically what I'm trying to say. Any differences in ring seal are going to really start to show themselves when you get into high vacuum. Also a question, is my 6.5 degree tilt of the phone to my screen, is that maddening or is that mad tight, yo? I'm just wondering. Let's see. Let me go to the chat here real quick. I know some guys said some stuff. Cobb base maps help alleviate some of the advanced timing from the factory. Yes, they do. They do relieve that again. Do Cobb. Which guy? There's a couple cute ones that work there. So let's see. I had a ID refresh for 1050 injectors, and the injector flows 1077, and the bottom flows 1069. The deviation was 3%. These puppies are 100% across the board. See, that's awesome. ID's got great injectors for that reason. Hey Dom, it's my car. You'll have to excuse the FP red. Everything was recommended. I also want to apologize for my friend. It's not his car and not his problem. Nathan Explosion. Oh, that's a good screen name. Right on, dude. Yeah, I didn't see that earlier during the stream, but again, I appreciate it. Are OEMs more accurate with their designed output? What do you mean by that? Are OEMs more accurate with their design? Do you mean OEM injectors, or what do you mean by that? That's James, right? I'm trying to remember the names here. Alright, so I'm not going to run 55 on this. I'm going to run 50 on it in this spot, and 54 right here. And so what this is starting to look like is, this buildup of timing is starting to look like an 06 WRX head, or timing. Because the different combustion chamber shape in that engine gives us a weird burn speed. It burns faster, annual WRX. It burns faster on the top end, but it burns slower on the bottom end, because they have more of a hemispherical set instead of a pent roof design on the those other cars. Active comparison. Okay, so comparison, you can see what I'm talking about. Here's that 55 again. This is a stock map from 06 WRX. Again, it's got that 55 in this region, 45 on this end here. So I might actually borrow this as my starting point for the tune for this region of it. That actually is looks like it's going to be about the trend that I want with this engine. And really up here on the top end too, it's not bad for this engine because of everything that's got done to it. What you'll see is it's very flat. The timing is very flat. That chamber I was telling you about in those heads burns really fast on the top end, much like a 2-valve LS or whatever. It doesn't have the same timing ramp that the pent roof in the STI head requires. Like the STI, from here to here is like a 10-degree swing, and here you see we only got 3 and change, right? That's not a big swing or a timing ramp, I should say. Like the STI head, you're gonna have a big timing ramp through here. 10 might be excessive, but it's just an example. It's like a lot of ramp. But this has very little ramp. And so this map with this car with cams and all that kind of shit would be a good starting place. It could be a safe starting place. This is gonna probably drive exactly how this car wants to be with the larger cams and everything, and then this is gonna be a safe time. I'm not gonna borrow all this stuff. I am gonna borrow this right here. This section right here, I'm gonna throw that over here and fuck with it a little bit and see if it likes it a lot. I think it will. What we've seen right here in this region is almost the exact same as the time map, so I'm gonna borrow that. I already have the timing way retarded here, as I showed you earlier, for safety, and then we're gonna start applying some power to it, that kind of stuff. So we're gonna borrow that because it's convenient, it's there, and honestly, I've never fucking done that before. I usually just go through like the whole thing, but as I started doing the stream and showing you guys, I was like, wow, that looks almost exactly like a WRX time map. I'm just gonna use that now, this time, and probably to here-ish, right about here, and then I will tweak it with it as I screw with it during the tune. But yeah, I've never actually done that, borrowed the WRX map right there. So you guys are here for my first time. It's my first time. Feels like the first time. Let's see, I'm gonna pull some out of here though, because I don't think this thing's gonna want that much timing around atmospheric pressure. I don't think it's want quite that much. Still some out of there, and still some out of here too. Again though, look at that, how flat that is, right? There's no ramp to it, and that's the difference between that and the STI. Look at all the ramp, right? So very different. Oh, for Travis quit, they are, and OEMs only use an injector enough to get the job done. Yeah, so to expand on what Travis is saying is, are they closer? Maybe. At the low pulse width, probably not. But the injector is so small that you're never in the low pulse width region. I'm still gonna tweak this map some though for what I want. The injector is so small on the factory injector that you're never in the low pulse region. So you don't need to worry about it that much, right? The injector is never gonna be operating at 0.5 milliseconds. It just isn't gonna happen, right? The injector is gonna be operating at 1.4 at idle or something like that. before latency, and then, you know, almost 2 after latency. So it's going to have a much larger pulse width, shit, maybe 1.5, right? And so if the injector's not in that low pulse region where they're really shitty and uncontrollable, then it's not even an issue. Like, it's really easy for them to work. But also, what the OEMs have, right, that's very different. This is, I did this on my Discord channel this weekend. I posted my ignition advanced lesson, and that transmission feels funny. Oh, your shifter, Justin, your shifter's goofy. It's missing a ring or something. Yeah. Huh, gotta fix that, partner. Oh, my arm's falling asleep. In my Discord channel, I provide lessons. And so the last one that I did this weekend was a lesson on ignition advance. But what played a big part in that ignition advance lesson was also the injectors. And I also had a customer email me. He was having tipping issues and sent me his tune that he was doing himself. And I was like, yeah, dude, the problem is the tipping values, right? He was under a few assumptions that weren't totally correct about how it was going to behave. And so I got to explain to him a little bit about why this really feels fucking crispier already with a time map in it. Explain with him how the injectors play a huge part. Well, what the injectors have is these 12 precisely drilled and aimed. Come on, let me go. Let go. Holes, right? And their atomizing plate. It's got these holes in it, and it shoots the fuel exactly where they want it to go. So if you ever notice, the factory injectors have a bunch of holes. They have 12 holes in there, 4 groups of 3, if I recall correctly. And the injector is also indexed to the rail. Like, there's a little clip that holds it at a specific orientation. And that is done on purpose. That's so that injector, those 12 holes, fire exactly where they want the fuel to go. And these 4 atomized sections, 3 holes each. Now, those little injectors don't put hardly any fuel on the port wall. Those suckers spray right at the back of the intake valve. Hardly any fuel goes in the port wall. And that results in an injector that's a very low, what we call impact factor. So that when the injector fires, it's not directly contributing fuel to the fuel puddle on the wall by impacting the wall itself. An aftermarket injector has a narrow cone. The IDs are a narrow cone because they can't have 12 precisely drilled holes, aim the fuel spray, you know, down 50 different ports at once, right? Because every engine's going to have these different ports and stuff. Some are going to be 2 valves, some are going to be 4 valves, some are going to have a split port, some are going to have a wide valve, valve separation, we're going to have a narrow separation. They just can't do that. And as a result of that, the injectors have a much higher impact factor because a larger quantity of the fuel that comes out of the injector impacts the port wall, the divider plate, you know, region of the port, and all that kind of stuff. But what it also does, it doesn't atomize as well. It doesn't have these 12 individual little cones coming out and making a fine fuel mist, letting it get atomized and carried in, right? It's got bigger, heavier droplets that take longer to atomize, and they don't, and they also come out in such a short period of time that they're not exposed to as many air molecules during the injection time. If you think about, if I have a tiny, tiny injector and I spray for 2 milliseconds, okay, say I spray for 2 milliseconds, that's not even that tiny really, and it's a super fine mist, it comes out really slow. Well, the air is passing by that injector, right? And in vacuum especially, there's not a lot, right? The air molecules are spaced out a bunch. There's not a lot of air molecules inside that port at all. So in that longer pulse time, as the few molecules go by, there is more to interact with the fuel. There's more to transfer energy. There's more because it has this longer period of time for it to happen, right? Now with a really short pulse width, I go, right? It just spits a bunch of fuel out. It's kind of like a loogie, right? It's not very fine mist and that kind of stuff. And it happens super quick. And there's only the air that is available in that instant in the port to interact with the fuel. It doesn't have to, there's not air moving by that point and interacting with the fuel during the spray. So you have this you have a higher impact factor, you have a slower evaporation time, it hits the wall, it takes a long time to evaporate, and it really messes with the whole tip in, but it also messes with the idle quality. If the fuel's not as well atomized, then it's not going to idle as well. It's not, when you already have very, very little air and fuel charge in the cylinder, and you don't have a whole lot of compression, you're not compressing a whole lot of it, and you have exhaust gas retained in there slowing the burn down, right? You have all those things working against you. The burn's going to be slow, it's going to be inconsistent, it's not going to be great, so it's not going to idle stellar. And yeah, you can make it idle acceptably, you know, that's no problem. I can make it idle acceptably, right? But it's going to have some misfires, it's going to have some, you know, little burbles occasionally. It's going to have, you know, you're going to hear that the idle just isn't as clean as it is on a factory injector, because it can't happen, right? You'd have to get a 1300cc injector custom made for your specific port design, making sure you don't have intake manifold spacers. They gotta know the angle of the injector. They gotta know all that shit. And then like, if you put manifold spacers on there, you pick that injector up. Now it's gonna hit more of the port wall, add to the impact factor and all kinds of stuff. So it's just not gonna be as good. And so the same thing happens to the really light loads with the short pulse widths. I bring in 2400 RPM. Yeah, I got 2400 RPM, but the vacuum is a lot higher. And so, and if you look at the fact that the fuel requested was even less than an idle, that tells us there's even less air molecules in that port per unit time going by that injector and getting into the engine. So it's just, it's not a recipe for a super smooth running engine. But let me tell you, and this timing that I did in this cruising region in light loads, it is a different car already. The torque and the response on the throttle is very apparent compared to what it was. So that's cool, right? That's good. But would it run smoother on stock injectors? Of course. Of course it would. Like, for anyone not to believe that it could or would, they be silly. Of course it will, you know? Yeah, I love my injectors. You know, I love my IDs. I love that company. They do a wonderful job. You know, but there's just a point that you got to understand that bigger isn't always better. And so when it comes to injectors, I always try and use the smallest injector that I can get away with. The smallest I can get away with is key. Not only does it make the car run better and smoother, you get better gas mileage. That better atomization. Better atomization means more even fuel distribution in the cylinder. Means less stratification, less pockets of air charge that are clumped up, and then there's none here. There's some fuel here. There's no fuel here, right? A more homogeneous charge of the cylinder means a more complete, more thorough burn, more torque, more fuel economy, etc. So run the smallest that you can get away with is always the strategy if you care about that. If you're just a fucking guy that wants to race and don't give a shit about how well it idles, you don't care if you got to run at 1200 RPM or whatever, then just run whatever the fuck you want, as long as it's huge and it's controllable, you know, enough to get idle and enough to get it to the staging lane, and enough so that, hey girl, and enough so that the, you know, the fueling is even in all four cylinders so that you can make the power you want to make. That's a good change. That's a significant change. I'm actually surprised at how much it really wanted that ignition advance. And that's a significant jump up, and that's like 20 degrees in some areas. But yeah, it feels really nice. I'm not seeing any knock counts or anything. The engine's not pissed off about it. It is clearly what it wants in this cruising light throttle, you know, region. And the tip-in's really close too. Could use a little more tweaking, and actually I have some tweaking done on that map that I have yet to flash, because I messed with the wall wetting and the tip-in and that kind of stuff on it. But the tip-in's actually still really good, but I see a big negative correction near the end of the tip-in event. As everything starts to stabilize again, there's a big negative correction. And that negative correction is because I put a lot of fuel in, and initially it was the right amount for what made it into the engine. But what happens is that impact factor I was telling you about dumps a lot of fuel on the port, and that port then it starts to evaporate off, makes the engine run richer again. So there's this trend where you have to put a bunch of fuel into it because you gotta get fuel into the motor so it doesn't run lean, but there's a surplus of fuel that hits that port wall, and then when you hit that port wall and it starts to evaporate over time, then it starts to dump more fuel back in the engine again. So you have this weird evap factor, evap time factor, that's the opposite kind of the impact factor, and then that's done outside of the synchronous event when you do your tip inertia, which is a synchronous event. So, anyways, my viewership just dropped by almost half. So I either bored the shit out of people, or those guys I'm paying to watch my channel to raise my viewership fucking logged off. No, I'm just kidding. But I do hear people do that. I have heard that there are purchased, people pay for views and that kind of shit. There's like companies that you can give money to. I guess politicians do it and shit so they can help spread their propaganda stuff on the internet. Yeah, I know. It's just me talking, trying to teach people stuff. And who wants to fucking learn, right? Learning's for nerds. Nerds. Actually, there's a guy who just started tuning recently, who told a friend of mine who tunes his own car that anyone could do it. It's not rocket science. Yeah. At least I was hoping you'd say it's not rocket surgery. That'd be the best. Because I like that expression. It's not rocket surgery. All right, let's see. It's not brain science. Okay, so I got that. I need a flash, which means I need my hands because I need to. Yeah, you know who I'm talking about too, right, Travis? Apparently he got angry at JR, at Junior there, and because they had a couple cars with issues that they blamed on the tuner, even though it was not the tuner's fault. And also talked much trash about IG, and he got in trouble with them. And now he's got his own tuning brand and shirts and everything else. Which is good, because hopefully that means more of the cars I don't want to tune will go to him anyways. I don't got to worry about it. Alright, flash this map. Let me flash. Oh, car locked me in. What's this got? Aftermarket alarm? Yeah. Get a DomTune. Or not. Or don't. All right. Got my blood drawn today. So I can evaluate my pancreas and other stuff again and see how fucked up it is. I feel like my pancreas and my prostate are in a race to see which one gives me cancer first. I don't know. We'll see how that goes. Yeah, can't possibly be the parts. Let's see. Okay, test mode is disconnected. Turn on, reset. Please turn the key off for 15 seconds. Yeah. Alright, let's see. Do you want to replace the map? Yes, I do. I don't like that map that was on there anyways. Because it's for other parts. Alright, so we're getting closer. We're getting almost to the phase now where I can do like a light pull. See how the boost control is at 0% duty cycle. And see what the car does. So I'm excited about that. The car fired right up. There wasn't even a crank. It was like I turned the key and it was like boom. So that was cool. Typically bigger injectors didn't always start that fast, but apparently I got it right this time. And that was an instant start, and it found idle instantly, didn't hunt or anything. That was actually, I wish I had it on camera. Here we are. Now this car doesn't have pulse dampers in the, it's got them in the rails, but not in the line. So a lot of guys don't realize those black pulse dampers that are at the very end of your fuel rail, the little black ones are actually for the noise in the line. That hard steel line runs through the cab, and if you lose that black damper, then all of a sudden you hear your injectors. Especially when you go to a bigger, louder injector like the 1300 or something that makes more clicky sounds. You'll get more of those noises inside. And in fact, sometimes it sounds like the engine's failing. You're like, oh my God,
a cam rounded off, right? My cam lobes have gone flat. Not to say that couldn't happen on this car, because it could, but it often sounds like that. And so sometimes you have to like go in the engine bay and go, I don't hear the click out here. They sit in the car and go, I hear the click in here. And then you know, oh, it's those damn injectors clacking away inside the metal fuel line. So sometimes what we do is either put the factory black ones on there if they'll fit based on the fuel system, or we will get the radium inline damper and put it right off the hard line. And that'll help knock down some of that clacky noise that we get. Okay, so now I'm logging back onto the computer. It's still not quite as smooth as I really would like it to be right here, but I think that's as good as it's going to get with everything that's going on. I think it's just as smooth as it's going to get. Unless, of course, like I said, it's a grounding issue at some point, which we'll find out later. Now, for some reason, this car doesn't have an intake air temp sensor in the intercooler pipe. I don't know why that didn't happen. I think it should have one. I think every car should have one. But luckily, it's got a front mount. No, this is an 06 STI. But it's got a front mount, so that helps stabilize the air temp, so it's not quite as critical. But if you go into speed density, however, then you run into an issue where it's, ooh, look how clean that correction was during that transient there. So here we are, I guess the throttle. I mean, that's a clean transient right there. The correction hardly, I mean, they didn't even go into the tens. That was down into the single digit. Oh, one little flash. So that's really clean transient. I like that. Message retracted. Hope all's with your health. You know, dude, I never fucking know. You never know. But nobody in my family makes it to be very old anyway, so I haven't been planning on it. Trying to live a life that I can have a good conscience, you know, and spread love among my friends and families. And you know, when I go, hopefully I left enough of impact on people that love me enough that they'll say that I was a good guy. Obviously, I'll have lots of people that be like, fuck that guy, glad he's gone. I totally anticipate that. But those guys just don't, they're truth phobic. Yeah, so we'll see. I'm sure everything will be fine. Look at this fuel pressure differential, right? You know you've got a good regulator on a car when that fuel pressure differential sticks. I mean, that thing sticks. Look how close that is all the time. From high vacuum to boost, that thing hardly fucking moves. That's a good fuel pressure regulator. And that's why I use the 4 Innovations F2Y regulator. I should do their video, their commercials. They don't have commercials, but the 4 Innovations F2Y. Look at that. That is, what? Like 0.1 PSI over a freaking 14 plus PSI range? Like, that is fucking unheard of. That's unreal. So, yeah, the 4 F2I is a fucking awesome fuel pressure regulator. I really like it. Not a sponsor, right? But if you're watching this, I want a fucking PayPal payment. I'm just kidding. Oh, someone's standing outside my door. He looks happy. What?
The inner threads are too tight. So all it wants to do is chew the inner tie rod as you thread it on.
Is it not a 20?
Huh?
Is it not a 20?
It's just too tight. They needed to run the tap back and forth like 10 more times.
So it needs like a 60% engagement instead of like a 75 or something?
It needs like a number 4 instead of a number 2 tap.
Is the peak too high or is the valley too deep or too shallow?
Peak too high.
The peak is too high, so it's cutting into the tire rod, the inner tire rod.
No, it's cutting into the sleeve that we made.
So the valley is too shallow.
On the sleeve, yes.
On the sleeve, right. So those are the threads that we did. So the valley is too shallow.
Yeah.
So it needs like a 75% because it's got a 60 in there or something like that, what you're saying.
Yeah, or just run the tap back and forth a bunch of times.
Right, or just put sandpaper on the inner tire rod. Knock those fucking teeth off a little bit.
Yeah. Do you have the tap?
No, I don't have it. Are you sure it's a 9/16?
Yeah. I double checked it. I tried 1.5, 1.75, and 1.25 on the thread pitch diameter.
Nothing.
Like not even close.
Okay.
The 125, it makes a full tooth extra, and the 1.5 is like kind of close, but it doesn't fit.
Yeah, I just figured, James, that maybe you could like jerk off that tie rod with some 100 grit.
So what? Yeah. Where's the tap at?
It's at the machine shop.
Where's that at?
Garwood. Kind of by where you live.
Yeah. Where at Garwood?
Garwood Road. Stancraft. You know where Stancraft is?
Yeah.
The boat place? Yeah, he's in their building.
Oh, really?
Yep.
Shit.
Or blood.
Yeah, because it won't go in there.
At all. Like
It goes on about an inch, and then it's too hard to hold the inner tie rod and thread the thing in. But it unthreads itself by hand.
So you're just chasing the threads a little bit.
Mm-hmm.
I mean, can you lubricate the shit out of it and just
I
turn it
can.
in with some shit and then turn it out and see if it cuts its own?
It gets to a point where there's too much friction to hold the inner tie rod.
Oh, that tight, huh?
Yeah.
You gotta use Penetro. Get that molly in there.
I tried.
I know, I'm just teasing.
I tried Penetro. I tried dielectric grease. I got anti-seize on it now. Nothing's.
Okay. Well, this is what it is. I can take it back to them and if it was the wrong pitch, it would get tight long before it got an inch deep.
Yeah. No, it's the right one because it threads on there perfect a little ways and then it starts getting hard. It doesn't really get harder until a certain point. Then it kind of like just kind of stops. You get like half a turn, and then you get like one more half turn, and that's it.
Really? I mean, it sounds like the wrong pitch, you know? Like it's super close. Like it's a 19
It's
and a
not
half.
messing the threads up though.
Right. Like it's a 19 and a half.
Yeah.
And you have so much surface area on the trailing thread that it's grabbing it.
Yeah.
But, okay. Maybe, yeah, it's got to just be deeper.
Yeah.
I will ask Ryan if he has another tap that'll free it up. Because if it's the depth of the cut, then run the tap in a couple minutes ain't gonna hold the depth any. Right? It's gone all the way down in the back already.
Well, unless you only made one run in it.
I don't know.
It just needs to be a little looser. Not by much, just a little bit.
Right.
Like I don't know what class that tap was, but
It was a expensive tap. They also broke a $280 drill bit doing them.
they did what?
They broke a $280 drill bit doing it, so they technically lost money on the job.
Why?
An issue with
Feed rate or something?
it was too short of a bit, and so as it went in, chips couldn't clear at the very end. It was a through,
Oh, yeah.
It was a through coolant one, and the way that bit was cut, it got fat too quick, and the chip bound up in it and snapped it right off. They had to use a slightly longer one.
That'll do it.
Yeah.
Alright.
All right, so let me calibrate the tack. Boy, that runs nice. All right. Look at his corrections. All right, 47.25 at 60. Let me set this down so I can calibrate that. Yeah, set that. Alrighty. Had to calibrate the tack on the Dyno. I'm gonna roll the wind up a little bit so it doesn't deafen me, but enough that you guys can hear it, hopefully. Okay, so I'm gonna do a light pull. I'm not gonna put this towards the thing because I need to hold the fucking wheel too. And at 0% wastegate duty cycle, see where the boost is going, see how the air fuel is tracking, and all of that. So let's do that. fuel is 10.8. Shouldn't be too bad. And the boost got to about 7. It's not like a rev limiter. That's weird. Maybe my map didn't take. That'd be 2 weird glitches in a row where it didn't take my changes. Whoa! Okay, the program crashed. This has been an ongoing issue lately. It seems like the Cobb Subaru suite has been crashing a ton lately for me. I don't know if it's just me because I have bad computer karma or what, but I'll go to a tip-in map, and almost every time, it's almost always tip-in. Any tip-in related table, boom, desktop. Does it all the fucking time. So she just crashed on me again. I'm gonna load a map. I'm gonna load. Oh, there's 2 different names on here. Interesting. I don't know why it's got 2 names. I suspect an issue. Let's see here. You motherfucker. Yep, there's the fuel. There's the rev limit being wrong. Timing's right. Is the MAF scale right? MAF scale's right. Alright. Is this still 0 with the... Oh, they moved... Oh, see, that's the old fucking map. You cocksucker. You dirty rat. Alright, well, let's compare that to the other map that I made for him. This one here that has a different name for some reason. Okay, there's some changes that I did. Yeah, and yeah. Okay, and then I did yeah, you fucking dick. So a bunch of my limits did not get transferred over, which is really weird because these are real-time limits, so you would think they get transferred over, especially when you fucking flash it. Yeah. I don't want to change that. Actually, I like the cam timing that we come up with during our talk here. Okay, that's now fixed. And then I had to go here. I changed a bunch of shit here. Is that right? Okay, that took. Okay, so that part took. That's weird. How about this one? But that change didn't take. Huh. That's alright. It actually runs good with it set right the way it is right now, so I'm not going to put that one on there anyways. We did that one together already. And I just changed that. Or not, I did not yet. Okay, 78. Sorry, you guys aren't seeing. I'm getting lazy with the phone as I'm trying to sit here and look at this shit. 7,600 is the current rev limiter, that's where it's set. Alright, so we'll save that. Hit it again. Alright. I'm going to flash it again. Even though it's almost all the changes are real time, I'm going to do it again just to make sure. Is the access port crashed? Nope. Okay. Gotta turn the engine off and... Damn your auto-locking shit! Alright, 1 second. One thing I hate about GDs, these fucking green connectors. At least these have been... Whoopsie! At least these have been used enough that they're easy to get to. They've been pulled down, they're easy to get to. Some cars, I'm the first guy to ever touch those green connectors. And it's a lot like the Virgin. You gotta get in there just right, really slow, loosen everything up and get it down to where you can actually do your job without breaking something. It's kind of a pain in the ass. It's slow and tedious. Whereas like right now, in a car like this, the connector's already hanging down. I can reach up with one hand, find the spot, like I've done it 100 times. In this case, thousands of times.
All right, let's do this again. Calibrate the throttle. Okay. All right. Let's go online again. Still feels good though. I like that. Still feels good. Take that, phone. All right. Let's do this again. Now that we don't have a crazy rev limiter. Some guy just looked at the dyno graph up there. What's making? It says 184 or something like that. So that's funny. Normally I wouldn't go that high on the first pull, but everything was looking so perfect I did. Everything was looking so good. Although there was no ABCS action there, so even without ABCS, everything was really damn good. Let's do that again. I bet it spools a lot faster. Okay, 340 at about 14 pounds. Not stellar, not a lot. Air fuel is in the low 12s. And the timing is crazy conservative, so that part's golden. Let me double check my, yeah. So I want to get a GR MAF and a GR Cob SF and put it on one of these, change the wiring and shit, of course, and see if I get the actual range of the GR MAF or the GR Cob SF has, because they'll do like 503 wheel, basically on that one, and I want to see if that MAF will run well on this ECU. It'd be an experiment. I think it would. There's still a 5-volt MAF, so I don't know why they want it, but shit happens. But it'd be cool to stick the GR scaling on here with the GR MAF that has more room and not need to go into a hybrid speed density like I have to with this one, because I'm going to max out this MAF at 348 wheel like I already did, and then have to go speed density like I have it set up to do. So. All right, ABCS working this time. Definitely came in sooner. Again, zero wastegate duty cycle, but the ABCS coming in gave us, at the start of the pull, we had 2 pounds more boost at the start of the pull, and then I reached peak boost about 750 RPM earlier. Let me show you that, so you don't have to take my word for it. Oh, fuck. That hurts to move sometimes. So the last pull, no ABCS, this pull with ABCS, see the difference? Even down here with the 20 degrees of advance, I'm getting more boost. And I bet more torque too, huh? Let's see what the torque looks like. Come on. Look at that. Look at the torque increase with ABCS. Isn't that retarded? Now this little means I can probably bump the ABCS up in this region a little more, or tweak it or adjust it to make it more, you know, straight line. But look at that. Look at the difference. With ABCS, without ABCS. Look at the difference. 250, 170, 180. So 70 plus foot-pounds by having some cam timing. And some motherfuckers like, oh, I get rid of ABCS, it doesn't do anything. You're a fucking idiot. ABCS is awesome. Give the horsepower. Woo. Oh no, look. It made more right there without it. Which means really I probably need to put it to 0 a little sooner.
on the table. Big difference, right? That's a huge difference. Cam timing's awesome. Alright, let's check out my log. See how we're doing here. No knock. I gotta hope, fuck, I had no timing on the damn thing. Oh, maybe not. I got more than no timing. I had 20 degrees on it. 22 at red line. 27 at red line. Okay, so it wasn't no timing. Yeah, I know. People do that shit all the time. There's people do kind of stuff they don't understand because someone said something on the internet once. I mean, you guys talk to me on the internet right now, so like, you know, if I was an idiot, and you thought that I wasn't, then let's see, 12.8, 12.8, not bad. So 20 degrees at 12 psi. That's nothing to sneeze at. I have 13 psi right here. I wouldn't want to run any more timing than that on this, on pump gas. I don't think the gains would be worth the added risk. 4, let's see, 7, and we're down to 0 by 7, pretty close at least. Okay. Got a little learning trend here at idle right now, 6%. That can be easily a function of this. 127 is high. I can guarantee you it is not 127 degrees into the engine right now. And so that's an issue with having the intake air temp sensor in the MAF. It gives you inaccurate readings. That's why so many supers blow up, honestly. It's because of this right here. Yeah. So if this had a relocated IAT, we would see this be 80-something degrees. Someone posts so many damn comments. I don't know what you mean by that. Are you bagging on my boy James for posting? This is a two-way conversation. It's a stream, so he, as you know, more than welcome to shoot the shit with us. Excuse me. And you too, if you have questions, you are more than welcome to make them. Comments, shoot the shit, absolutely. All right, let's go back to this again. Let's see here. Air fuels were clean on that pole. The previous one, they were a little spotty, but that one cleaned up quite nicely. It's pretty flat. It's a little on the rich side. High 10s. High 10s is a great place to start, right? We definitely like high stuff. I get everything in my fucking pizza. I love pizza. I love pizza with pineapple too. Watch my viewers go from like 16 to 4 by saying that. Pineapple all the pizzas. Yep. Let's see. What do we got? But you see, my family is from Hawaii. So I'm the first generation born on the mainland. My dad was born in Hawaii, his dad was born in Hawaii, and his dad was born in Puerto Rico. Oh no, my grandpa might have been born in Puerto Rico too. I forget if it was Hawaii or Puerto Rico because it was right around that time frame. But they moved from Puerto Rico to Hawaii to work the sugarcane fields in the 40s. I think it was the 40s is when they all moved over there. It might have been the 30s. Well, I got pictures from the 40s and 50s of like my grandfather in the army, I think it was, living in Hawaii. So pineapple, and so it's kind of cool because Puerto Rican food and Hawaiian food have been a part of my growing up, my life, my whole life, and even some Puerto Rican Hawaiian fusion foods, which is interesting. But there's pineapple on a lot of shit, so. Alright, so we're gonna add some boost. If everything worked out so well on that pole, we're gonna add some boost. What I want to do is I'm gonna start the poles later. So with this dyno, because it's a speed control, like a speed ramp control, if you start the poles too early before there's any torque on the engine, it actually ramps too fast. And it isn't representative of what happened on the street. So it behaves almost like you're in second gear instead of fourth. So I gotta bring the starting point of the pole closer to some boost. I screwed that up. I gotta start over. Do it again. Sounds good. Alright, so you're gonna see why I do that. Second, let me double check the pole, the log. No knock, that's good. Timing's pretty conservative now. Now we're getting down into the low teens for timing. I got 14 at 4,800. 06 STI, FP red, 13 hundos, ported heads. I forget which cams, but cams. Front mounts. It's got a Cobb SF on it. No, right now we're on pump gas. I don't even think he's got a flex fuel sensor on here. Justin, do you have a flex fuel sensor on here? I don't recall. No, not yet. Okay. Yeah, all you said was no, but I wanted to add in the not yet because not yet's the correct answer. All right, so I'm gonna show you the difference by starting the pole, and I also add some wasted duty cycle, which helps. But starting the pole later, the boost starts a little higher because it right here. Obviously, I added 20% wasted duty cycle. That's gonna help it too, but that makes a difference, and the whole thing comes in even sooner and earlier. And that's more representative of what happened on the street. If I started here at like 4, the boost would be like up here at 4, which I will also do at some point. And that's more like a 5th gear pole versus a 4th gear pole kind of thing, if you're doing it on the road. So I'm gonna clear all these things off. Go back to that last pole. See this right here? This is the switchover point from MAP to speed density. Now, what we can see is that I have a good VE because it's good and flat in this region, but my target's too low here because this is, you know, MAP control. I need to verify that my target is in the 10s. It usually is. Breaking MAP's usually in the 10s. But if I bring this to 11, this will still step up some here. So I have a right trend on the VE, but the value is low. So I'll lean out the target back into the 11s, and then I will take this area of the VE curve and I will up the VE, which will lower the fuel, make it richer, add more fuel to it. And then we'll get this line to be straighter. So I'll have to do that. And then we're gonna keep adding boost, because right now we're at like 17.5-ish, and doing pretty good. Still laggy, it's an FP red, look at this laggy bitch. 55 hundo, full boost, and that's getting on the pole late. I'll do it again, like I said, around 4 grand, and we'll see peak boost probably around 5,000 RPM, but it's still a red, so it's gonna be laggy, but this number is gonna be pretty high in the end. What's up, what you got?
So, Subarus are 14 by 1.5,
Okay.
which is the closest thing to 9/16/20.
Okay.
I tried to thread this on a Subaru rack, no go. It's like a turn and a half in, and it's like, nope.
Right, so it's not like the pitch is wrong.
So it's 9/16/20 is what it is.
Right.
Something's wrong with that.
Right.
I just wanted to double confirm. I was like, well, shit.
Yeah, maybe.
Maybe I fucked it up.
Right. Okay.
And Moog is, I can't get a fucking red pitch from him. I don't know why. I can get one for everything else, but.
Yeah, weird.
So EV127 is the inner Tyron part.
For the T-Bird?
Yeah.
Gotcha.
Yep, 89 through 97.
Yeah.
and about 400 other Ford cars.
How's the length on it? Does it look like it's going to be right?
Length's going to be fine.
Okay, cool.
Halfway threaded into the outer tie rod, it gives us about 3/4 inch of threads on the inside. So it'll be like mostly threaded on.
Perfect.
So we'll have some
It'll be as strong as it
3/4
needs to
there,
be.
plus 1.5 inches on the other end.
So it's gonna be super
way-
strong.
Yeah.
Cool.
Yeah.
Yeah, that'd be great.
So it'll all work.
Just need to open it up a smidge. Or sand down that tie rod. Alright, so let's do the first thing I said. Check the fuel target. Look at that, high 10s, exactly what it's doing. It's actually almost in the mid 10s. So it's a little bit, but we're gonna take this out now. I want it to be 11. So we're gonna go 11, and then I'm just gonna fade that into up here to this 11.2, up here like that. Smooth that in, and then I'm just gonna merge all this stuff in with the other numbers, just to get it closer. And then we're gonna use a lot of smoothing right now because it saves a fuck whack of time. Do some H there, some of that, and oopsie, it's hard to do one-handed. Fix that. There we go. That's what I was trying to get. There she's going. I was off one square. It was not. There we go. And this guy. Look at you hiding in there. Less fuel. Less fuel. Less fuel. All right. Lean is mean, baby. And she sees the meanest. Just kidding. All right. And a little bit of that. All right. So that changes the fuel in math control. But now I gotta go look at the VE curve. Alright, so that means that down here on the VE table, where the switchover point is, looks like it's hitting right at 65, and we're at 17.5 pounds of boost. So 15 plus 17, okay, and a half. So we're right in this region, 65 right here. And you see the VE actually drops quite a bit right here. And with these cams, that's obviously not the case. So we'll bump this whole lower section up a little bit. Actually, yeah, we'll bump this whole lower section up. The VE is not dropping as fast as I have it dropping on the tune. So if I turn this way, you can see kind of this slope right here is how fast I had the VE dropping. That's more of a stock cam VE dropping off. And these aren't stock cams. So we're going to add a little bit of VE in that region. 65. Add some VEs. Add some VE to this map, you see. Alright. And you know what? I just realized I fucked that up. I just fucked that up. Because I had the right curve. It was flat, right? So it is supposed to drop quite a bit. There it goes. It just needs to go up. Did I see that very well? Bloop, 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 bloop. Okay. Alright, little Mo VE up in there. Alright, let's see what happens. Alright, I'm anticipating a change. I'm anticipating that really rich region comes up, right? That's the anticipation. I'm anticipating that my leaner target prevents that from dipping down so far. Now that initial spike down, that's a little bit of the wall wetting tables, and I can tweak that wall wetting table some to minimize that spike, the dip technically, right? That dip down. And then that flat line, that's hitting target. We're thinking it's hitting target, but it actually was. I had 10.5 as the target, so there we go. So that should come up, and then the end of that should stay about the same, hopefully. I didn't do any math. Technically, you can spend time and do math and figure out exactly what percentage it's going to be based on all the things you did, but you do this enough times and you can get a feel for about what it's going to be. So let's do this and see if I was even close to being right. Roll up into sums. Well, the short answer is kind of. That top end stayed where it was at pretty much, which is what I wanted to do, right? I was leaning the target out, but then adding VE because I want to stay the same. But that other area only leaned out a little bit, which is kind of odd. It did lean out some, but not nearly enough. So I'm gonna check a few compensations and see why. Let me show you. I don't know if you can see it or not. So you can see on the top end there, pretty flat still, slightly leaner than the previous. And then some lean areas, a little leaner, but not as much as I want. It's still a big dip. So that's going to be some of that wall wetting action. Fuel temp is still pretty high. Air temp is still pretty high. Both those things will definitely screw with it. No knock or any of that biz, so that's good. Timing is about as aggressive as I'd want to run it on a street car. Boost was the same, if not a little bit less than the last pull, just from sitting and not being close to a second pull, but nothing appreciable. So this, I'm going to add a smidge more fuel to that same area, and right at 7K, I'm going to add VE. It's 7K right here. I'm actually going to add it right here and smooth it to the other side. Okay, add VE there. And then I'm going to raise the whole thing a little bit. Whoops. Raise the whole shebang a little bit. See if I can add a smidge more fuel to it. Okay. And then that 7K spot, I got to blend that shit in. I'm actually going to put the phone out so I use both hands to do this faster. Give me a second. I can grab this guy. 103 right here. Alright. I want to get some spikes out of there I didn't like. Okay, so I got that part now. But now my problem is, why is it so much? Let's double check my hybrid mode where I have it switching. Make sure I got that where I think it's supposed to be. I have set just the MAF, right? Yep, just the MAF, 4.8 volts. I don't like doing it with other things. I want to do it when the MAF's almost maxed out. Okay, open the fueling. That's still 11 something. That seems fine. Double check the injector, make sure I didn't screw anything in there. That's right. Those are even. There's no added fuel. Okay, I'm gonna go down to these guys, miscellaneous tables. Airflow post cranking, none of that. And then we go here. Load compensation. Okay, it's got some of that. That's a factory thing. -6 at idle. And I'm looking, I got +6 at idle right now. I should just zero that out. Okay. Intake air temp. Okay, so here's one thing. So we got 3% fuel being added at high intake air temps. Where's it at? There we go. And we're high right now. Remember I showed you guys we're 120 something in there. So we're adding fuel because intake air temp is high. Now that's for safety's sake. But I want to make sure my VE map is correct. So I don't want to have this correction right now. I definitely want to add that in at the end of the tune so that if it does get this high, then that's right. But I want to make sure my V map is correct and my targets are hitting where they're supposed to be outside of other compensations. So I want to zero that out again. Like it was from the factory. That's my own compensation that I do. It's zeroed from the factory in most of these tunes. So I can ensure that my VE table is correct. Alright, so 3%, that doesn't seem like it's that much. Like that should be 3% is yeah, let's lower this down. 3% is not as much as the fuel is off. So I'm going to reduce the wall wetting base right here. This one is responsible for a lot of spikies. So we're gonna do that. Those two changes alone should alter the fuel quite a bit, and then Cobb changed this, and I hate them for it. Wish they hadn't done that. It's annoying as hell. Okay, I'm gonna get the green connectors. Oh, my balls! I know my personal life shouldn't bleed too much into these videos, but I had the old snip done last Friday, and I think they could have done a better job. I think it could have been nicer with the hardware, if you know what I'm saying. Yeah, I'm not loving it right now. I'm not, definitely not digging it. Parts of me are purple that shouldn't be purple. I mean, jokingly people say things are purple, but when they actually turn purple, on for reset, turn it off for 15 seconds before starting, let it sit. Yes, replace the old map. All right. So I added 6% at idle. I added 3% in power because of the high air temp. I reduced the wall wetting. Now that could bite me. We'll see how it behaves when I'm tipping in and I'm doing those accelerations that I showed you before were so freaking crispy and perfect. I just changed tipping pretty significantly by changing the wall wetting in there. And so that might bite me. I might be lean now on tipping. So that is always a possibility. Remember, there's always a little give and take when you're tuning, right? Okay. Control L, let's talk to it. Come do buddy head. Oh, I coughed COVID. You're all getting COVID now. You're all dead. You're dead, you hear me? You're dead! I think some correction idle right now. That's kind of weird. That's opposite of the direction we went before. Interesting. Oh. Yeah, that's weird. Alright. Still good. Correction. It's actually a little aggressive up top. Which is weird because I pulled fuel out. This guy right here, commanded fuel final, that's important to watch. When you first start a car and you're in post-start enrichment, that number is lower. And so you definitely can't do pulls if you're in post-start because it's adding fuel because it's post-start. So you gotta watch that and make sure that it's nothing crazy. In this case, 6.2 is like exactly where it should be. If we go to our closed loop control, closed loop target, load, 0.1-ish from stoic. Hey, look at that, 0.1-ish from stoic. So we know that we've cleared our post loop or post start enrichments and we are on the closed loop target map. Now, one thing I can do actually in that area where I had the misfires and not quite as smooth as it could be, I can add, oh, look at that. It's actually lean. That should be negative, not positive. Interesting. All right, there we go. So I added a little bit of fuel at idle there. Actually, that'll help it not run so rough. And then in that light load areas, I can actually increase the target, make it like 14.5 or 14.3, something like that. And by doing that, that typically helps smooth out those rough sections. that helps sometimes. Obviously right now that's a reflash only map, so that's not going to change anything right this very second, but that'll help me later on. If you have 1700cc injectors, you pretty much always got to do that. If you're doing pump gas on your 17s, you need to raise that target, or lower that target, increase the fuel. Alright, let's see. It's leaner. The dip is gone, and the fueling is a lot flatter. There's a little bit of a dip there, but not nearly. Well, cleared it up so you can see it. What time is it? That's something in the Carter tune. Oh, I gotta hurry up. I might have to stop the stream because I can't operate as effectively with the stream going and talking to you guys. Let me show you the difference. There you go, look at that. See, now we're up in the 11s. Oops. Now we're in the 11s. And it's much flatter and dip down nearly as far. A little bit of dip here. But I'm going to leave some of that in because that helps, for one, with rapid changes in engine load to have a little extra fuel in there, keep from knocking and everything. So I'm going to leave a little bit in there, but you get an idea now. See, that's a lot flatter than it was. And the boost is only 17.5. So I'm going to crank the boost up to like 21, 22. And can't get any higher than that. Oh no, that's not true. Not stock not anymore. That's right, we're on the top floor. I got the 21, 22, which is a good pump gas number. And we should break in the 400 wheel horsepower range by then. My dyno's acting funny. That number is actually higher than it should be. The correction is showing me a correction for atmosphere that's really high right now. I don't know why it's doing that. I might have to adjust that. I don't want to give fake readings. That's not cool. So I may have to see why the correction is so fucking high right now. I think the weather station gets glitchy sometimes, so I gotta like reset the weather station. So I bet that's what it is. Anyways, it's not that important. I don't really give a shit about numbers. Numbers aren't what I'm shooting for. What I'm shooting for is a driving experience that's good. Car that feels good, drives good, makes lots of powers. So let's add some boost. There's no knock on that last run either. None any so far during this whole tuning section. So I can't bitch about that. I'm gonna dump this fucking waste CO2 cycle. I'm gonna put the waste CO2 cycle higher than it should be because I want to see if the boost control PID controls. That's a lot of controls. If the boost PID controls are set correctly to compensate for transients or departures from target. So let's see what happens. That's second, not fourth. Alright, so I hit about 20 psi on that run. It did finally give me a knock event. There's one there. And looking at the air-fuel trend here, it's because it was lean. With the higher boosts came the earlier switchover point to speed density, and I know now that that area of the speed density, map, the VE map that I haven't got to yet, well, you know, I haven't got into that zone yet, is not high enough. So at a lower RPM than what we were doing earlier, I need to add VE to it. Because in that section it ran leaner. It hit 12.0 for a split second and then dipped into the region where I've already adjusted, where you guys witnessed me adjust that. So I need to raise VE from 55 to 65. So the 1,000 RPM below what I'd already been screwing with. knowing that trend is carrying up into, or up, I say up, it's up the map, but it's down in RPM, right? I'm going to raise the VE at the bottom end, or in the lower RPM regions of the whole thing, because we know now that we have a lot more VE down there. Now, this isn't a full speed density tune, this is a MAF to a hybrid speed density. If this was a full speed density tune, usually what I would do is I would do the entire VE map. I would hit every square that's possible hitting and hold it for 10 seconds or so. But that's just not feasible in today's tuning session, and it's not required, because I'm not going to be hitting those areas outside of, I'm not going to hit anything at less than 4.8 volts on the MAF, so I don't need to do that. But I am going to add VE to the rest of the entire map due to everything I'm seeing today. And that'll just ensure that if for some reason his mass airflow sensor fails, or the boost gets super crazy wonky and spikes up at a lower RPM than it would ever normally do, like maybe the boost control line broke off, or who knows what. I mean, it's a Subaru, lots of things can happen. Then he'll be protected. It shouldn't run too lean on him. Boy, it sure is slow if you're doing what I'm doing right now. I should turn off the data stream too, because it makes the changes really slow because it's a real-time table. There we go. It's a little faster. Alright, those VEs look a little excessive in the low RPM regions, and I'm fine with that. I'd rather it run rich for the guy. If there's an issue and he can get it home, then have it be lean and he can't drive it. So, in normal operation, he should never hit this. He should never hit this map, this part of the map. But if he does, I'll make sure he's got the fuel. Try playing ahead. Okay, so that's good. See how that does. Looks like it wouldn't let me get in the safe spot. Let me clear this table and look at it again, or this chart, look at it again. Yes, it did. So I added a lot of fuel to the tune, but it didn't do anything. So I need to check fuel pressure. Fuel pressure, is it dropping or is it the same? Fuel pressure is rock steady. Okay, so it's not a fuel pressure problem. Fuel pressure is steady as can be. Why'd it go lean? Commanded fuel, 11. Oh, there is a spike in commanded fuel right here. Interesting. Yeah, it's right there. Why? there's this low spot. It's low load. Commanded fuel leans out in here for some reason. Let's see if we can figure out why that is. MAF table is fine. It does drop a smidge right there, but not through that long of a range. So you go to 300, 301, 295, 298, 300, 310, up again. So it's increasing fairly normally through there. Absolute pressure is increasing normally through there. Tip in, last applied. Turbodynamics, we're still less than the boost target. But why? What's going on here? 19 pounds. Boost is just coming up and then stabilizing. My phone glitched for some reason. So calculated load dropped. Right at 300. Let's check that out real quick. So the MAF calibration, 300 is at 4.7. I have the MAF switch over at 4.8 here, 320. So unless I have a hysteresis thing going on with that, and it's starting early, and that's happening. Let's check that out. Whoops. It's up here in speed density, hybrid mode. 4.8 with a hysteresis of 0.25. So that could be part of it. I'm gonna string the hysteresis up anyways. And yeah. Map 60 psi, so that's not part of it. RPM 8000, that's not part of it. TPS 105, that's not part of it. Ramping. MAF to SD. So this value is very low. If I raise that, it'll ramp faster. From MAF to SD. Lower all, upper single, okay. Lower MAF, upper SD. Yeah, that's all correct. How's my smoothing? Smoothing's pretty decent. That's all good, that's good. That is... that's not great. That's not great. I want to ramp a little faster. That's a lot faster. Okay. And that guy. What is that bug? Never seen you before. Some little bug on my arm. I think he liked me. He was tickling me. I don't think I like this anymore. I don't know why I have it this way. This seems backwards. I don't want that. I don't want half that. I want to not lean out too much when air temp gets high. I mean, some is obviously correct, but I don't want to get too much. Let's see. Is this all zeroed? That's zeroed. Okay. That's not a thing in this case. Oh yeah, god damn it. Disconnect. Flash. Yes I am. Green connector is a pain for me today. Hey Justin, you still in here? sure you're probably at work doing stuff. Jealous of the outside temp, right? It said 160 on the dyno. I think that's what's wrong with it. This thing glitched out on me. It's weird. This lean spike that I'm having here is not typical for this type of setup, but sometimes it would happen a long time ago. And IAG had their rails with the dampers you could buy. The dampers turned out not to be as well calibrated for this fuel system as previously thought, and what happened at certain levels of boost, around 5,500 RPM, you get this lean spike. It didn't look like this. It looked literally, it would come across, the fuel was good, and it would go bloop, bloop, and it was this weird one spot, right at 55-ish, this big mountain of leanness that nobody could figure out what it was until we took the dampers out. So I didn't do it. I think EQ Tuning or somebody did. And then, holy shit, the fucking spike was gone. And that was a bummer because the dampers were in the whole point of those was to minimize that type of behavior, and then they actually caused that type of behavior in the car, which sucks. Now, they definitely helped when the car was in vacuum. Lost service for an hour. Me or you? Because I lost service fucking for 12 hours, my internet provider. But yeah, so they definitely... Oh, Jim, your cams. I took inventory on the cams. I want to make sure I had them because I got a bunch of orders that came in all at once. And I told the guy again, motherfucker, weld my shit. And he went, oh my God, I'm sorry, I forgot. So we're gonna get these things welded here pretty soon. And I have 3 orders to send out for AVCS guys. So I got to get that hole plugged, and then we'll start shipping cams. All right, I gotta reset the weather station. My phone's about to die too, but I gotta reset the weather station because it's reading stupid high. There we go. It says 84 degrees now. That's more like it. I need to change this. All right. Thanks for sticking around. It's the last pull I'm going to broadcast because I got to finish up and my phone's down to 17%. So I gotta plug the phone into my car so I can use it. I've been broadcasting now for 2 hours and 6 minutes apparently. Alright. Need to get live with ECU. it ever will do it. There we go. Bring the logger up. Check my commanded fuel. That's where it should be. I like that. I opened the hood hoping to get more cool air in here, but yeah, not working. So that was a lot richer. That was a lot richer. So that ramping rate and the air temp compensation were playing a big role, apparently. Alright, well, I got some work to do. And then I got to tune in the car, and I'm running out of time today. So thank you guys for stopping by. Let's see any last minute questions. Let me double check. Officers for an hour. We talked already. Chelsea has a temp. Yep. Pain. Anytime. Late. HD dinner pizza. They're the same. Okay. So looks like I got everything. All right, gentlemen. Thank you very much again for stopping by. And I'm sorry it was so long from the last one. I think it was like almost 2 weeks of my last stream. Sorry about that. Things have been going on. Work on the Corvette. I should do a stream and show you guys the Corvette progress. Completely taken apart, and I got a whole freaking scenario of shit I want to tell you about that. That still fucking baffles everyone I talk to. It boggles the mind. So I'm gonna share that with you guys either tonight or tomorrow. It's pretty fucking interesting. But thanks guys for sticking around. No problem. Nathan Explosion, which is not Nathan.